Hi everyone, this is Mrs. J, and today we're going to be graphing tangent functions. But first, please pause the video and give this warm-up a try. All right, go ahead and check your work here. We have that reflection over the x-axis, vertical stretch by a factor of 3. This one's a little tricky, a horizontal shrink, because the factor is the reciprocal of that b value. So the factor is 1 over pi. And then we have the vertical translation up 5. All right, so let's look at some characteristics of tangent graphs. So this is 3 periods of our tangent parent function. It doesn't end here at 3 pi over 2 or negative 3 pi over 2. It would just keep repeating infinitely to the right and left. So these graphs are periodic, just like sine and cosine. But you might notice that they look pretty different than sine and cosine. So one major change from sine or cosine, besides just the general shape of the graph, is the period. So for sine and cosine, it takes 2 pi to complete a cycle, but for tangent, the period is only pi. So the period is half as long. So this is our parent function period, and you see from negative pi over 2 to pi over 2, you can see that it completes a full cycle and then it resets again. So our period for the parent function is shorter for tangent. Another feature that is quite different from sine and cosine is that it has asymptotes. And in fact, it has repeating vertical asymptotes. So we are going to practice today describing a way to write something that repeats infinitely. So the first thing you're going to do is name one of the asymptotes. The parent function will always have an asymptote at pi over 2. If you look at how far apart all of the asymptotes are, they are all 1 period apart, which is pi. So if you want to describe something that's repeating every pi, so that would be every multiple of pi, what we can write is we could write plus pi n. So this is how often it repeats, and n for us is going to represent any integer. So we're essentially adding any multiple of pi, so plus 1 pi, plus 2 pi, plus 3 pi, or minus 1 pi, minus 2 pi, minus 3 pi. So this is a way to describe something that repeats infinitely. Again, we name one asymptote, and then this is how often it repeats. So you do plus that value times n. And that will be a way to describe every infinite vertical asymptote that exists. So this is a little bit tricky, but the setup's always going to be the same. So once you've done enough of them, it becomes easier. You'll notice that our domain is also restricted because of the vertical asymptotes. So we're going to write this in inequality notation. It's a little easier. So I'm going to say all real numbers except, it's literally going to be everything except the asymptotes. And this may not be something that we're going to describe every single time, but just so you note that the domain is not all real numbers. There are undefined values for these. We did see this when we were evaluating trig functions for different angles, and we did see that sometimes tangent is undefined. So that's why our domain is not just all real numbers. And then the range, this graph does go up and down forever, so this range is all real numbers. I don't know why I mixed up my notation, but either notation is fine. All right, let's talk about our strategy for graphing tangent. And we'd have a different strategy than sine and cosine because our graph is so different than our previous 2 trig functions. So first thing I'm going to define is the period. So this process is similar to sine and cosine. Right? We're going to look for this horizontal stretch or shrink by a factor of 1 over b. Remembering it's the factor is the reciprocal. However, you'll notice that the little formula we can use to find the period is different. Instead of 2 pi over b, for tangent it's going to be pi over b, because remember the period of our parent function is just pi. So you take your parent function period and you're essentially multiplying it by that stretch or shrink factor, which is 1 over b. Once you have the period, I'm still going to divide your period by 4, and I'm going to use that to scale the x-axis because tangent is still split up into 4 parts. There's an asymptote, there's 3 points, and then there's another asymptote. So there are still 4 parts to our to our tangent graph. So we're still going to use that same rule to help us scale our x-axis. Then we're going to sketch in the asymptotes. So you might have noticed in the picture, I'm going to sketch a little picture over here, that tangent was centered around the y-axis, right? We didn't have an asymptote on the y-axis, it was centered around it. So if you want to center something around something, you go half the distance to the right and half to the left. So we're going to be going half a period to the right and half of a period to the left to place our asymptotes. So half a period, we're just essentially going to count 2 tick marks to the left and 2 tick marks to the right, and this will work as long as we scale our x-axis appropriately. And then we are going to repeat our asymptotes every period, which is just going to be 4 tick marks. Then we're going to plot our midpoint. So that's the point that, and the parent function goes through the origin. So there is something that can affect that midpoint. If we have a vertical translation, which would be that k value, that is going to shift my entire graph up or down, which I will start by shifting that midpoint. And the midpoint is the point that's halfway between my asymptotes. So if there's a shift up, then that midpoint would shift up, and if there's a shift down, then that midpoint would shift down. Then I'm going to look for what I call the quarter waypoints. So that's 1 tick mark to the right and left of the midpoint. So the vertical distance, if you look for those, the vertical distance from the midpoint to the quarter waypoints is always going to be A. So this distance here is A, and this distance is A. So again, it's the vertical distance from the midpoint to my quarter waypoints. So if that distance is A, there is something we should look for that could affect it, which would be a vertical stretch or shrink. So you might notice that we're not listing an amplitude for tangent. Tangent doesn't have an amplitude like sine and cosine, but it will still have A values, and it will still affect our graph, but what it's going to affect is that vertical distance between, again, the midpoint and our quarter waypoint. So whatever that A value is going to be that distance. And then once we have those 3 coordinates and we have our asymptotes, we know the general shape of our graph. It's going to make almost kind of like a cubic shaped graph, and it's going to travel along my asymptotes going down and up forever. And unless we have some type of reflection, each of our periods is going to be increasing. So we start down and we travel up. All right, let's give one of these a try. So here we're going to graph 2 times the tangent of x. So first for my period, I notice that I don't see a b value, so that means my period is unchanged. It's the same as the parent function, which is pi. So to scale the graph, right, we take our period and we divide it into 4 pieces. So that's how I'm going to scale the graph. So pi over 4, pi over 2, 3 pi over 4, and pi. And it'd be the same on the left, but in the negative direction. Now for my asymptotes, remember, we go half of my period to the right and half to the left. Since a period is going to be 4 tick marks, if we've scaled appropriately, that means we're going to go 2 tick marks to the right, which is half of a period, right? If my period is pi, half of a period is pi over 2. And then I'm simply going to go 2 tick marks to the left, another pi over 2 or half a period. And this will set me up for 1 period of tangent. Let's see if we can add in another couple periods. So remember, the asymptotes are going to repeat every period, which for us is 4 tick marks. So if I go 4 more tick marks to the right, I will have another asymptote. And if I go 4 more tick marks to the left, I will have another asymptote. Okay, so let's see if we can describe these asymptotes. So first we're going to describe one of them, x equals pi over 2. And then we say how often it repeats, which is just always going to be the period. And then we multiply that by n, so plus pi n, and n represents all integers. You don't have to write that. If you write n, I'm going to assume you mean any real integer. Okay, so now we can look for our midway point. So I see that midway between my asymptotes is right here at the origin. There's no shift up or down, so I'm going to simply place a point at the origin. Now remember, there is something else I need to look for, which is that vertical stretch or shrink. So since I see a 2 right here, the vertical distance to my quarter waypoints is going to be 2. So I go up 2 units and then over 1 tick mark. I call this my quarter waypoint. And then for this one, I would go down 2 units and then over 1 tick mark. And then I'm going to simply sketch in my curved graph that will follow along the asymptotes. So remember, this distance, this vertical distance is A, and so is this vertical distance. So that's how a vertical stretch or shrink will affect our graph. Now let's see if we can repeat that process for another period on the right and on the left. So we just, again, we find the quarter waypoint between, or the midway point between the asymptotes. And then for the quarter waypoints, that vertical distance is 2. So I go up 2 units over 1 tick mark, down 2 over 1 tick mark. And I repeat the shape. And it is going to travel along the asymptotes. There's my middle, up 2, and down 2. So once you have one period in the middle, you're really just replicating the pattern to the right and the left. All right, let's try another one together. So here I do see a b value. The b value is 1/2. So that's going to be a horizontal stretch by a factor of 2, which is also going to affect our period. So remember, for the period, we do pi divided by b, and pi divided by 1/2. Well, dividing by 1/2 is just multiplying by 2. So our period is 2 pi. So for the scale, I'm going to take the period and divide it into 4 pieces, like we always do. So I'm going to count by pi over 2. And remember, since we want to center the asymptotes around the y-axis, I'm going to go half a period to the right. So pi to the right, it's always going to be 2 tick marks if we scale our graph or our axis correctly. And then I'm going to go pi units to the left, half a period to the left. And then if you look at the distance from here to here, from negative pi to pi is 2 pi. We can continue that pattern. All we need to do is count 4 tick marks. 1, 2, 3, 4, and 1, 2, 3, 4 to the left. So this will give us 3 full periods of f of x. Let's describe these asymptotes. So remember, we start by describing one. So x equals pi, and then we say plus, and then how often it repeats. It's going to repeat every period, so the 2 pi is the period. And then we say n for every integer. And again, we don't have to label this, it's just to show you what that means. So it's essentially saying I can add 2 pi, I can add 2 pi times 2, I can add 2 pi times 3. And all of those multiples of 2 pi will just describe this repeating asymptote pattern. All right, from here, I don't see any other transformation. So my graph is not shifted up, so my midway point is going to be at 0, or it's also not shifted down. And my a value out front is 1. So that means my vertical distance to the quarter waypoints is just up 1 unit. So I go up 1 unit, and then to the right pi over 2, down, and to the left pi over 2. Then I know the general shape. It kind of looks like a cubic function, and it follows along the asymptotes. And then we're just going to repeat that in the period to the right and the period to the left. And again, this vertical distance is A, which in this case is 1. Same for this vertical distance, it's A. So when you don't see a number out front, that vertical distance is simply going to be 1. All right, let's try another one together. Here, I don't see a b value, so my period is just going to be pi, which is the period of the parent function. So for the scale, I'm going to still split it into 4 parts. So it's pi over 4, pi over 2, 3 pi over 4, and then pi. But again, for the asymptotes, to center it around the y-axis, I'm going to go half a period to the right. So 2 tick marks, which is pi over 2, and then 2 tick marks to the left. And it's always going to be, the period is always going to be 4 tick marks because of how we scale our graph. We take our period and divide it into 4. So we go another period to the right, and we can do another period to the left. All right. Now for our midpoint, we do notice a different transformation we haven't worked with yet. This graph is going to be shifted down 2 because of that vertical translation. So for my midway point, instead of being at 0, I'm actually going to move it down 2 units. So all of my midway points are going to be down here. Now my a value is 1, so the vertical distance to my quarter waypoints is 1. So I'm going to go up 1, and then to the right pi over 4, and then down 1 and to the right, or to the left pi over 4. So you need to start by placing your midway point, and then from there you go up a units, and then to the right, whatever you're scaling by, and then same to when you're going down. And then we simply make the cubic shape, follow along the asymptotes, and then just repeat that pattern in each period. There you go. So again, that vertical translation up or down is going to shift your entire graph, but the way we approach it is by shifting our midway points first and then adjusting the rest of the graph. Oh, last thing we need to do is describe the repeating asymptotes. So again, name one asymptote, doesn't matter which one. It can literally be any asymptote that exists. I'm going to pick pi over 2. It's going to repeat every period, so we say plus pi n. All right, one more together, and then I'll have you try one on your own. Let's look at how a vertical reflection affects our graph. So there's no b value, so the period is still pi, which is the parent function period. I'm going to split it into 4 pieces to scale my x-axis. Pi. Then I go half a period to the right, so pi over 2 to the right and pi over 2 to the left to set up my asymptotes, and I can do 4 more tick marks because that will be another period. All right, this one there's also no shift. Oh, let's describe those really quick. So again, name any asymptote, pi over 2, and it repeats every period. So it's always going to be plus the period times n. All right, there's no shift up or down, which means my midway points are at 0. My a value is 1, so typically I would go up 1 and then to the right 1 tick mark. However, there's a reflection. Because of that reflection, I'm going to go down and to the right. That distance is still going to be 1, but instead of going up and to the right, I'm going to go down and to the right for each period. And when I do that, you'll see that instead of having an increasing graph in each period, now I have a decreasing graph. So when there's a negative out front, your graph should be going down in each period, and that is reflected over the x-axis. So remember, before our graph looked like this, it made this shape, so now it makes this shape. So that's what's going to happen whenever we have that reflection. All right, I have one for you to try on your own, so please pause the video and give it a shot. All right, so for this one, the change that we see is that vertical stretch by a factor of 3. So our period is pi. I'm scaling it by pi over 4. I have an asymptote. Well, my asymptotes are at pi over 2 plus pi n. Remember, name one and then add the period times n. There's no shift up or down, so my midpoints are at 0. But remember, with the vertical stretch, it will increase that vertical distance to the quarter waypoint. So I went up 3 over pi over 4 instead of up 1 over pi over 4. So make sure you have that really stretched out looking graph. It's a little bit harder to make this look like a curved graph, but just do your best. All right, go ahead and pause the video and give this one a try. All right, go ahead and check your work here. So for this one, the only change we see is that vertical translation up 1. So you'll see that all of my midway points are shifted up to y equals 1. From there, I go up 1 to the right, pi over 4, down 1 to the left. So this vertical distance is still 1 because there's no vertical stretch or shrink. It's just all of our points have been shifted up 1. Our period is not changed, and here's our repeating asymptote equation. All right, one more for you to try on your own, so please pause the video again. All right, let's take a look. So here we have a b value of 2. So for our period, we take pi, we divide it by b, so it's pi over 2. Because this is a horizontal shrink by a factor of 1/2. Our period has been cut in half. If I want to split that period into 4 parts, I'm going to scale it by pi over 8. And again, I go half a period to the right, which is pi over 4, and half a period to the left, negative pi over 4, to set up my asymptotes. From there, it's every 4 tick marks, because 4 tick marks is 1 period. So you can see my asymptote equation is pi over 4, which is 1 asymptote, plus the period times n. Now there's no other transformations. My midway point is at 0. I go up 1 over pi over 8, down 1 over pi over 8, because there's no vertical stretch or shrink. So our graph actually ends up looking exactly the same as maybe the parent function graph. The only thing that changed here is actually the scale of our x-axis. So it is really important that we scale it correctly and that our scale is shown on our graph. All right, so now we're going to try a couple that have multiple transformations in one. So here I always check the period first. The period is going to be unchanged because there's no b value. For the scale, split your period into 4. And we're ready to place the asymptotes. So we go half a period to the right, 2 tick marks to the right, 2 tick marks to the left, and we can repeat that every 4 tick marks, which is the distance of a period, as long as we scaled our x-axis appropriately. Now here there's 2 changes. First, I'm going to look at this translation up 1, because that is going to shift my midway point. So notice that instead of being at 0, now it's at 1. And then I also see that we have a vertical stretch, which will affect the distance to my quarter waypoint. So instead of going up 1 over pi over 4, I'm actually going to go up 2 over pi over 4. And down 2 over pi over 4. And then we just connect our coordinates and do your best to travel along the asymptotes. And again, it's this vertical distance, that a value. That's how the vertical stretch or shrink will impact our graph. And then our asymptote equations, we name one, pi over 2, and then plus your period times n to represent all of the repeating asymptotes. All right, let's try another one together. Here we have 3 changes. We have the reflection, a period change, and a shift down 2. So let's talk about the period first. So remember, we take pi and we divide it by the b value. So pi divided by pi is 1. So this time our period is 1. Remember, the period does not have to be in terms of pi. Sometimes it is, lots of times it is, but sometimes it's not. So for my scale, I take the period, which is 1, and I divide it by 4. So I'm scaling it by 1/4. And then I go half a period to the right, 1/2, or 2 tick marks, and half a period to the left. That allows me to center it around the y-axis. And then I'll go 4 more tick marks, which is 1 more period. And I know that there will be an asymptote every period. Okay, so I've taken care of this. Let's write the asymptote equation. One is at x equals 1/2, and then it repeats every 1 times n, or you could just say plus n. All right, the next thing I'm going to look at is this vertical translation down 2. So I'm going to move all of my midway points down 2. Instead of being at 0, they're going to be at -2. My a value is 1, so that vertical distance is going to be 1. But then here you notice we have the negative. That reflection makes our graph go down instead of up. So from the midway point, I'm going to go down 1 to the right 1/4. And I'm going to do the opposite on the left. So you'll see that our graph ends up decreasing in each period like this. And so we go down 1 to the right, and then up 1 to the left. And again, that vertical distance is still 1. It's just in the opposite direction because of the reflection. Okay, here's the last U try, so please pause the video and give it a shot. All right, we got a lot going on with this problem. First, we do have a horizontal stretch by a factor of 4. So our period changes from pi to 4 pi, or you can do pi divided by your b value, which is 1/4. And remember, dividing by 1/4 is just multiplying by 4. So if you split that into 4 parts, your scale is going to be pi. I go half a period to the right and half a period to the left for my asymptotes. Here's my repeating asymptote equation. Then you'll notice our graph was shifted down 1. So if you look at where all of my midway points are, they're down at -1. And then last thing to consider is that vertical stretch by 2. So I'm going to go up 2 units to the right pi and down 2 units to the left pi instead of up 1. And that's what makes our graph look a little bit more stretched out. All right, that is all for today's lesson. Thank you so much for watching.